This video is for pre-calculus, where we're just practicing some more in-class practice for section 4.2, where we're comparing exponential and linear functions. So these were a couple extra ones that are not in your packet that I did in class for practice. And this first one, it says, find the formulas for the exponential functions in this figure below. So I have two functions here. And the reason why I like this problem, and it's even, so you haven't done this one, is that if you look at our two exponential functions, this one right here, P, is a cool one because I know the initial value. This is a 0.020 or my y-intercept. But for Q here, I don't know that. So you can actually find the formulas a couple different ways. You can use them both for the ratios, but I wanted to show you for P first. So let's find this one first. So I see I have the initial value 0.20, and then I have this point here on P, which is 1040. And 1040 is basically on both graphs. And I look at it, and I could do a ratio here, but since I know my initial value, if I know y equals ab to the x, I initially can, right off the bat, if you will, put in the 20 in the a spot because I know it. This actually cuts down all your steps to just one more step, and I'll know my formula. So I put the 20 right in, and then I'm just going to plug in the 1040, this right here, in the y spot for 40, in the x spot for 10, and then solve for b. And I know it's growing, so it's going to be over 1. So if I divide both sides by 20, 40 divided by 20 is 2 equals b to the 10th. And then I'm going to raise both sides using the power to the 1/10. And I hopefully will get my b over 1. And when I do, I get 1.07177. So I'm really happy about this because now I know the formula for p is going to be y equals 20, 1.07177 to the x, which means it started at 20 and it's growing 7.177%. And remember to make your b over 4 decimal places. So I just found p. Now I'm going to find Q, so let's kind of go back up to our graph. Now Q, oops, sorry about that. Q, if you'll notice, I have 2 points here. I have the point 1020, and then I have this point right here, 1520. Excuse me, 1040, and then 1520. I'm sorry, I misspoke myself. So here I don't know the initial value. It looks like it's going to cross up here pretty high if I were to look at this graph. So I don't know my initial value, so I'm going to have to do this one with the ratios, which a lot of you are getting really good at doing. So when I set this one up, I want you to make sure is I always usually put the larger x on top just because I won't have negative exponents, but it really doesn't matter. So I'm going to put in the y spot 20 using the same formula, y equals ab to the x. So in the y spot, I put 20 equals ab to the 15. Divide, and then I'm going to put in the point 1040. So in the y spot, I put 40, and the x spot, I put 10. And now, in this case, over here, we found the a first. This one, we're going to actually find the b first. So thanks for playing. So 20 divided by 40 is an easy one. It's 1/2 equals, at same base, I subtract my exponents as b to the 5th. Now I'm going to raise each side to the 1/5. This should be getting pretty easy for you. We've done this over and over again. So now I know b, and oh, by the way, this one's decreasing, so I know my b was going to be between 0 and 1. I just want you to always look at that. So I got a 0.870551. So I found my b, and it's over 4 decimal places, and it's decreasing like I thought. So now I have y equals a 0.870551 to the x. Now you get to pick whichever point you want to plug in. We can use the point 1520 or 1040 from above. I actually use 1040 just because it seems easier. So I put a 40 here from the y spot. I'm solving for x. So I have 0.870551, and I'm going to put 10 there. And since this right here is hooked to the a by multiplication, my a is actually going to be 40 divided all by that. So it's 0.870551 to the 10th. So my a comes out to be I think this comes out nice. Yeah, 160. So everybody asked me, how do I round the A? For the most part, you can go 1 or 2 decimal places, but the more accurate you are with your B, the more accurate A is going to be. So this one actually comes out to be y equals 160.870551 to the x. And it does look like it crosses pretty high. If you were going to look at this picture, it looks like it would cross pretty high. So there's a practice for that one. And in fact, you should be able to do this and kind of see if you know how to do this, because we've done this a lot. Okay, number 40. 40, I like this one as well, because again, we're taking some data and we're actually seeing which one is better, or which one, what would the model look like if it was linear growth or exponential growth. So this one, it says, according to the College Board, the average cost of tuition, including fees, room and board, at a private 4-year nonprofit college has risen from $24,071 in 2003 to $30,094 in 2013. What will the average cost of tuition be in 2023, assuming linear growth and exponential? Well, if I give you something like this, I always kind of underline what they gave us for information and see if I can make points out of it. And I'm going to use time as 0 for 2003, just because they just gave us 2 points, and they're starting this from 2003. So my first point, and this is going to be for both of them, is going to be 0, $24,071. This is money, and this is years since 2003. Okay, so that's my first point, and it's pretty cool because now I know I have my initial value for both of these formulas. The next point is 2013. Well, 2013 is 10 years after 2003, so I can now put a 10. This is so much nicer than if you put the whole year there. And just make sure that you know your formula is from 2003. Okay, so there's our 2 points. So if I'm going to do linear growth, I have y equals b plus mx. I know right off the bat in the b spot, I can put $24,071. Okay, now all I have to do is find the slope, and I can stack and rack and do that. For the exponential, I have y equals ab to the x because I have my initial value here. I know right off the bat that this is 24,071 b to the x. So I only can do that if I know the initial value. So now what I'm going to do over here is actually find the slope. I'm going to use some Christmas colors here. So slope, I'm going to stack and rack and do bottom up, is 30,094 minus 24,071 all over 10 minus 0, or 10. And it looks like it's increasing, so my slope better be positive. And when I do this, it comes out to be 602.3, which is $602.30. So if this is dollars, this is year, this is per. So my slope is $602.30 per year. That's my slope. It's increasing that much per year. So now my formula, I'll use T for tuition, is going to be, it started out at $24,071 in 2003, and it's growing $602.30 per year. I'll use a little t. So there's my linear formula if it was constant every year. All right. So now I'm going to come over here and do the exponential growth. Well, again, because I know my initial value of 24,071, I can just plug the other point in there. This makes it a lot easier to do. Let me erase that. And then what I'll do is solve for b. So it's 24,071, b raised to the 10th. Now I can divide by that. So it's 30,094. Divided by 24,071 equals b to the 10th. I don't care about b to the 10th. I want b to the 1st. So I'm going to raise it to the 1/10 here and the 1/10 here, the whole thing. I'm using Christmas colors. And now I know my b, and it should be over 1 because it's growing, is 1.02258. So that makes me happy because it's growing. So my tuition equation, if I assumed it's exponential growth, is going to be t equals, starts the same just because I was given that, and it's going to be 1.02258 to the little t. All right. Now, the one thing I want you to know is this one tells me that it's starting at $24,071 in 2003, and it's growing. Cover the one, move this over 2.258% per year. Now, the rest of this question says, hey, in 2023, according to these both models, what would the tuition be, right? So I have to figure out what I'm going to put in my equation. And what I want you to do is make sure you show me this because this happens all the time. So I'm talking about 20 years later, right? So I'm going to throw a 20 in this one. I'm going to throw a 20 in this equation and find out what my tuition would be. So when I actually plug the 20 in here, this is what I get, $36,117. That's if it was linear growth. If it's exponential growth, it would be $37,621.80. And that's if it's exponential, and it kind of makes sense that it's more. But that's a good practice between linear and exponential. That's the end of this video.